Have to separate you two?
Yes.
All right. Where are we at? Which section?
2, 3, number 6.
All right, so 2, 3, number 6. All right, so number 6 says, you see that? Let's see. Zoom in.
That's better.
What is the class width for this given histogram? What are the approximate lower and upper class limits of the first class? So the class width, how can you tell what the class width is? Let me zoom in on that picture now that we know the question. So class width, visually, what's the class width? No, you don't have to calculate it. You don't have to calculate it. They've already created the histogram. Yeah, so you have to do that if you don't have a histogram yet and you want to make one. But if somebody's already done all the work, you just see what they did. The class width would be how wide the
bars.
the rectangles are. Yeah. So if you look at it, let's see.
It's like 4.
Yeah, see how it's not quite. This is really evil.
Oh yeah.
It's not quite 5, right? So you just kind of approximate it. So in between 45 and 50, it fits about 2.5.
Yeah.
Right? So 5 divided by 2.5. 2. So it looks like they're with 2. 2, 4, 5. You guys kind of with me? So you do have to figure out how wide a rectangle is, because then that would be your class width. Each rectangle represents a class, right? Good, good, good. So that's a really good question. Don't try to do any work there. You don't have any data to do work with. Yeah. The other question was, what are the lower and upper class limits? That's easy enough now. So here's my first class. So what's the lower limit? What's the upper limit? Now that we know it's the width of 2.
1.5.
So the upper class limit is obviously 45. So since it's a width of 2, the lower must be 43. That would be 2, right? Okay, right. Okay, so don't let that be too hard. It's not hard. Okay, so they already made the histogram for us. A lot of the work's been done. We just have to look at what people did and say, oh, it must have been a width of 2 because that's how wide the rectangles are. Sweet. Good. Yes, sure. Nobody else is saying anything.
How do you find the normal frequency?
Normal frequency. You mean the relative frequency? No.
Normal frequency.
So where's that coming from?
I think it's 2, 2.
I mean, you can ask if something looks normally distributed.
No, it's something else.
Yes, it's a normal frequency. I'll let you think about it. Yeah, there's nothing known as normal frequency. Yeah, they talk about normal distribution. Yes, I'm not sure.
I'll find it and
Okay.
we'll get back to you.
So visually, how would you tell if the histogram looked normal?
It looks like a bell.
Looks like a bell. Starts low, goes high, and then goes back. Well, good. All right, sweet. So you can have one that looks very normal, or you can have one that looks loosely normal. Yes.
Is there a reason you didn't go over cross-sectional, retrospective, and prospective?
Yes. Look at that. Because sometimes I will on purpose not cover certain things that will force you to read your textbook. So do you have a question related to that, or was that it?
No, I'm doing online homework and it had a bunch of questions on it.
Good. You should in the textbook too, in the written homework.
Figure it out. Okay, it's cumulative frequency.
Oh, okay. All right. So if I make a frequency table, say I have a frequency table looks like this here, 40 to 42, 43 to 45, 46 to 48, so forth, right? Blah, 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 blah. And I say I have 7 there, 11 there, 2 there. The cumulative frequency, it's just too long a word for me to, I lost interest. So once I get to this class, how many do I have so far? 7. Now at the end of this class, how many do I have so far? You accumulate your data points as you go.
Okay.
Right? And of course at the end, you better have a cumulative frequency equal to the how many data points you've got. You should have hit them all by then, right? So this would be 20, and so forth.
Thank you.
You're welcome. Okay. So I am definitely not a walking, talking textbook. So there will be certain things I will, on purpose and sometimes by accident, not cover that's in there. And that's why you had the textbook. So I try to expand on some things, and I leave some things alone so you guys can read through them yourselves. So don't freak out and think, man, did I doze off temporarily? No, I just didn't say a damn thing about it. Anything else from homework? So last time we finished up chapter 2, believe it or not. So today we're going to get into chapter 3. That's crazy how that works. And here's my plan for today. I want to definitely do 3.2. And then we're going to get into 3.3 a little bit. And then next time I got a little handout. 3.3 is actually one of the most important chapters we'll hit so far, right, by the time we get there. It introduces something called standard deviation. Right? And if you know anything about statistics, you know that that's a huge thing. If you don't, all right, you'll find it. So 3.2 talks about various ways to find the center of data. And if I just say that to you, what's the center of some data? So if I gave you some data, here's some data just sitting there staring you in the face. There's data. What do you think the center of that data is? All right, I love it. All right, good. What we call the average, which is sort of a bad name, really, because average in statistics means two different things. The mean. So in English, when you hear the word average, it normally references the mean. So one way to do this is use the mean, which is just another name for average. And that should make sense why that would be considered a center, right? If I find the average grade, everybody's kind of like around that grade on both sides of it, and it's sort of like a center. Now, in another respect, it's very much not the center, right? So if I took, how would I find the mean of these things? Add them all up. So this is going to be our first statistical equation. You ready? This is so exciting. I've got to capture this on film. Okay. Film. I love that. So in English, the average, which we're going to use the word mean now, because math people like it, so 4-letter word starts with the M. I don't know. In English, this is add all up, right? And then do what with them? Divide by how many there are? The number of them, right? Number of data points. Okay, cool. And we all know this, right? You know how to calculate the average. If you don't, okay, now you do. And somebody help me out real quick. Is anybody doing that for me?
16.8.
So this, let's say this is a population. We'll call it a population for now. Oh, let me do this. I'm sorry. Let me do this. Oh, that's horrible, Jim. If it's a population, it would have the symbol, are you ready? It'd have the symbol mu. Sounds like a French cow or something. Mu. Do you want? So the population, I mean, if it's a population data, if it's a population characteristic, then it's going to have, normally it's going to have a Greek letter to signify, sort of like the Super Bowl has Roman numerals, population, right? And now you ready for this? Add them all up. So the symbol for add is the Greek capital letter S, which if you know your fraternities or sororities, that would be sigma, right? And exactly what am I adding up? Now, these are a whole bunch of numbers. But let's say they represent, I don't know, ages of people. So how many variables do I have up there? Not how many values, how many variables? One age. How many values do I have up there for the variable? Okay, beautiful, right? You guys with me? So if I would have said ages and alcohol consumption, hopefully that's a 0. That would be 2 variables with 8 data points, 16 little pieces all together. So the population mean, I use the symbol mu, add them all up. So I'm adding up all the variables, and of course what letter do we use for variables? X, all the variable values. There's one variable, so I add up the values of this variable divided by the number of data points. And the book uses a capital N. It's kind of stupid. Just N means the size of what you're looking at. The number of things in your sample or your population. How are we doing so far? So
what's X again?
that's what it always is, really. It's the variable.
Okay.
Yeah. So add up all the values of this variable and divide by the number of values, the number of data points. So what gets people down about statistics? I told you this first day. There's no word problems, there's none of that, but there's a lot of formulas you got to figure out when to use them, and there's a lot of Greek letters. Right? And they all represent different variables, so you got to be able to plug stuff in. This Greek letter is a little different. It's not a variable, it's a operation. Right? It says sum, whatever the hell comes after it. So real quick, a little side note. What is the sum of x from up here? Who's done that for me? 135? How would you do this? Let me help you out. It's not the same thing as this. This one says add up the squares of the value. So I'd have to first, so this is a list of x's. I'd have to make a list of x squares. You with me? You try that again. Are you guys with me? Does that make sense?
Yeah.
Okay, good. I really want you guys. Now, what does this one say? Add them all up, and then of course I would just square 135. Good. So you desperately have to see the difference there. And this popped up in math before. Remember this evilness here? Right? That is 4, so that's negative 4. So it's got a negative in front of what that is. This is 2 negative 2's multiplied, so of course the negatives cancel. So that's the whole idea of parentheses, changing things around, right? So this says square that number. Well, that number is 135. This says add up these. Well, I better make those first before I can add them up, right? This is huge. That kind of thing is going to happen to us in a lot of different formulas. So if I saw this in a formula, what would I do first? No, Kara, you actually can do that. But let's just stay away from that. Because the algebra of this would be a whole semester worth of class.
Is it the summation of x minus 2?
So what would you do first? I would take every x value and subtract 2. So I get 12, 9, so forth, right? Because what's it saying to do? Sum up all these values. Well, how can you sum up these values if you don't have those values yet? Just like this guy. How can you sum up the squares of them if you don't have the squares of them yet? Right? Okay, good. Which is different from this, which would just be what?
The summation of x minus 2.
And what is that?
Just all x values.
Number 133. Right? 135. What's the sum of x? 135 minus 2. 133. Good. So those parentheses change things. We know that. We should desperately know that. We know it screws us up sometimes, right? And you're all like, damn, average, all that freakiness. That, of course, is just getting you ready for what's coming. This is a very simple equation. If I were you, I wouldn't even use the damn equation, because we know how to find the average, right? But this is a really good introduction to the symbols and what they mean and how they work together. Okay, so what did we get? Let's actually calculate this. It'll be 135 over 8, which comes out to be 16.9, roughly. Yes?
When you're doing the mean, aren't you supposed to throw out like any numbers that are obviously not? No.
Only in certain cases. I mean, when you're doing a statistical study, some outliers are really obvious. So if you were writing down people's heights and you saw 60 inches tall, that's fine, right? And then you saw 70 inches tall, that's still good. And then you saw 148 inches tall, I think that's somebody made a mistake. You would throw it out, right? But sometimes it's not so obvious, but you have like 100 data points all right here, and then one there. And you're like, oh, that's probably an error. Let's just throw it out and focus on this. So the whole idea of outliers, we're not going to worry about it yet. This is strictly find the mean of your data, period. In the homework, there's a question about what's called the trimmed mean, where you chop off the top few numbers and the bottom few numbers, and it gets closer to the real center. You kind of with me? The quickest way to screw the mean over, to make it not get the right kind of feel for the data, is to have one really big value or one really small value. Right? So if I wanted to work at a company, and I ask somebody, I'm just coming in there, just feeling it out, and I say, hey, what's the average salary people make here? Right? Let's say there's 4 people and a CEO that work at this place. Right? It's Ted's Corner hot dog stand, and people make this is in the thousands of dollars. Cool. People make 40,000, 42,000. Oh yeah, hot dogs are big. 47,000, 50,000, and then the CEO makes 450,000. And somebody comes in and they say, what's the average amount somebody makes here? They don't really want the average. Because what do you get? Somebody help me out. What is the average of those? What is it? I think it's 124 or something. 125. What is it?
579 plus 50, I don't know.
125? 0.8? Okay. Roughly? Now, if you told me that, oh yeah, we make $125,800 on average. Dude, I'm working there. So is that a good measure of center to use? So thank God Jeff put a 1 there, which implies there's another measure of center. So the better measure of center for things like income, or, for example, let me show you a couple things before I get too far here. So I actually justify why I did this. So here's gas price chart for the last year. Notice, what are they actually plotting here? Can you guys see that? What is it? What's being plotted there? Look at the title. The average. Cool. So they averaged all the gas prices at all the different gas stations. That seems reasonable. Right? Some gas stations are a little crazy, but nobody goes to like $11 a gallon. If they did, right? You guys so far so good? And of course, here's the average temperatures, right? Especially in San Diego, we don't get a lot of extremes. Right? El Cajon gets a little more extreme, but still, not crazy. So taking an average makes sense. There's no like 180-degree days. Tomorrow, stay inside. Maybe go in the basement if you have one. Right? No, we don't have to do that. Now look at this. Here's home prices. Now, it's a little bit of reading here because you see you hit, right away you hit something interesting. What's the word up there that maybe we don't know yet? Median. So the median price, anytime you see anything about home prices for, see here it says the median price up from $416,500, right? Somebody get a couple of those. Here's a whole bunch of data from San Diego Data. What was I looking at here, Jeff? Find it. Here it is. I lost it. There it is. Median household income. So, median is the number to use when there's these extreme values that would throw your mean off. It wouldn't make it truly representative. Are you guys with me? So there are situations. Those two are the big ones. Income, because you got the crazy people that make millions of dollars. And home prices. Just go to La Jolla. Walk around for a little while. Go, yeah, that's $6 million home. Right? So I'd rather use what's called the median. And real quick, I'm sorry, before I get too far away, I forgot that I did only the population. If this was a sample,
The X bar, right?
exactly, it would be X bar. Instead of mu, it would be X bar, but the funny thing is it's the same exact formula, right? It's just that if I say X bar equals, I know I'm dealing with a sample. So, which one of these is a parameter? Mu. I love it. So this is a statistic because it's talking about a sample. I love it. Cool. All right. So before I get too far away, that's the symbol if it's a sample. And that's the symbol if it's a population. Median doesn't really care which one it is. It's always this symbol. All right. It's like a mean that had something fall on its head. Yeah.
So you would use it with, you said, income, prices, and...
Income, home prices, anything where there's a chance that there's an extreme value that would throw the mean off.
Okay.
You with me? So once we figure out how to calculate the median, we'll go back up here and calculate the median and see if it makes more sense to somebody. The $125,800 is just lying, right? That's not honest, right? So the median, let me show you a couple things. Where's the median in the road, of course? In the middle. So if I have an odd number of data points, the median is really easy to find. What number is right in the middle? 4. Now notice something about the data. How was I careful to write this data so it made sense? I wrote it in order. Ascending order. Doesn't really matter because the middle will be in the same place. But I do ascending order so that the median makes sense. If it didn't have to be in a certain order, then why would we even have median? It could be any damn number you want it to be. And you can lie all day long. Right? So you got to put them in order for the median to make sense. So in this case, the median is 4. So what's the median income for this company? 47,000, yeah. So that's much more honest to report to somebody. Hey, what do people make here on average? No, the median is 47,000. Oh, okay. Not $125,800. It's crazy. So what if there's not an even number of things? So if I had 49, 50, 62, and 71.
The average of the two middle ones.
I love it.
50 and 62 and divide it by 2.
Good. You add them, divide by 2. You find the average. So when I have 5 things, let me not flick you guys up. There's an obvious middle dude, right? When I have 4 things, there's 2 middle dudes. So the middle of those is definitely the middle of the data, right? And to find the middle of any 2 numbers, you just take the average. So here the median would be... And of course, you could, this is 12 apart, so the median would be 6 up from one of them. There's other ways to find it than adding them divided by 2. But in this case, the median would be 56. Cool. Notice when there's 5 things, which data point was the median? Which 1, 2, 3, 4, 5? Which data point was the median? The third one, right? When there's 4 things, the median was the 2.5 one, right? We see it. It's the first, second, and a half. That's the 2.5 number. Only math people would come up with that, but right? But it is. It's the 2.5 number. That's what it is. So there is a real cool little rule of thumb to get to the median. Every time I say that phrase, I always think about, anybody ever seen the movie Boondock Saints? Mm-hmm. Rule of thumb comes from that big one. No, watch Boondock Saints. It's awesome. So to find the median, especially for the really long list of data, right? Because I don't want to kind of do this thing where I just count into the middle for 1,200 data points to get the middle. No, oh God. So I want to find like a quick way to get there. So here's the quick way. How do I say this? It's a 2-step process. First step is you do this. And that tells you where the answer is. And let me show you what this means. No, Jeff, not where the answer is. Where the answer is. And then the second step is going to be go get the answer. So for example, when I had 5 data points, what's n? 5. So if n is 5, the first step would say, and this, the reason that we use the letter D is it's kind of like, it means the depth. How deep into the list do you want to go? So that's why the first step tells you how deep to go. So the second step is go that deep and get the number. Right? So what's 5 plus 1 divided by 2? 3. So the third number is the answer. Right, so we have to circle it. The third number, and that's why we took, for example, that one, 1, 2, 3, we took 47 was the answer. What if there's 4 numbers in your list? What would this say? Yeah, it would be 4 plus 1 over 2 is 2.5, right? So how do you get the 2.5 number? You take the second and third and average them. You guys kind of...
The right answer when they're in order, though, right?
Exactly. Behind all of this discussion is they have to be in order for this to make any sense.
Okay.
Cool. Yes, ma'am.
So what does it mean, your third number?
The third number. So count in first, second
Okay,
numbers.
thank you.
Third.
I didn't see that list up there.
Okay, cool. So if you have 5, you count to the third. If you have 4, count to the second and third and average them to get the 2.5 number. If I had a list of 811 data points, where would the median be? The 406th one. So any odd number, you'll get exactly something, right? Any even number, you'll get average of the 2 in the middle. Good. How are we doing so far? That's relatively easy mathematics there, right? Cool. Another measure of center. And what's kind of mean that we've done so far in a way is, what kind of data does it make sense to use for the mean and the median? What kind of data would it have to be able to do this? Quantitative. So I want a measure of center that actually also works for qualitative. That would only be fair, right? So the third measure of center works for both quanta and qualitative. And it's called the mode. And the mode is the number that occurs the most. I love it. Either the number that occurs the most or the thing that occurs the most. So if I looked at hair color, and here it looks like black or brown maybe. Right? One of those would be the modal class of hair color. The hair color that occurs the most. So that's why I can use it for qualitative data. Or if I have numerical data, what's the mode there? It's crazy. Mode's 1. What is the mode here?
1 and 7.
How many modes are there? 2. So it's bimodal. Man, if I could write, you guys would love it. Bimodal, so the mode here is 1 and 7. By the way, there's no real symbol for mode. Like the mean gets x bar and mu, median gets x tilde. Mode is left out. Poor little dude. Right? And then I think the book goes to trimodal and all that, but I always say after this it's basically no mode. But I think the book does say trimodal. Let me see if I remember correctly. Oh yeah, this is multimodal. That's just silly. So if there's now, what about this though? Yeah, just be careful. If there's a clear winner, there's one mode. Right. There's a lot of ties there, but they're all ties for second place. So here the mode is definitely 8, because it occurs the most. Cool. Okay, so that's pretty simple. Okay, good. Oh, one more measure of center. That we use is called the mid-range. What am I at here? 4th measure of center. And this one is just almost too simple. It's not really used very often because it's too simple. But remind me, what's the range? Yeah, the range was the high minus low. It's like how far our data ranges. So the mid-range should be the number that's in the middle of the...
Average of the highest and lowest.
Exactly, the middle of the high and the low. So the biggest mistake I see here is people key in on the word range and they think minus. But the mid-range requires me to average these. So it'll be high. How do you average high and low? Add them. And divide by 2, right? That's how you average two numbers. Add them, divide by 2. Biggest mistake I see is people put a minus in there, but that doesn't make sense for averaging. So what's the mid-range for that list C? 1, 1, 4, 4, 7, 7, 8, 8, 8. What's the mid-range? Yeah. 8 plus 1 divided by 2, which is 4.5. Cool. Let's calculate all this stuff. So we already know the mode for this was 8. What's the median for this? So how'd you get there? Let me do it this way. Doot, doot, doot. Where am I at? Doot, there. There's an odd number of them, so there's definitely going to be a clear middle. So the median is 7. And what's the mean? 4, 9 is 5.3333. Oh, somebody help me out. Yeah. That's the only way I can show off, so I got to do that every now and then. Can't dunk basketball, but I can do that. All right, cool. So, I mean, the problems in this section 3.2 are going to give you a list of data. They're going to ask you to calculate all these, right? And then they might ask a few questions about, does it make sense to use the median here over the mean? And that's like we talked about earlier. If there's any like extreme values in there, you'd say, no, I'd rather use the median because there's an extreme value. Does that kind of make sense? So there will be a mixture of a lot of computation, but there will be some conceptual questions in there too. Okay? There's a whole thing at the end of section 3.2 that we're not going to worry about at all. And that's, I think here it is. Page 86, at the bottom of page 86, calculating the mean from a frequency distribution. We're not going to do that. So don't worry about it. But I will do one thing sort of related to that.
Measures of spread.
Huh?
Measures of spread.
No, that's section 3.3. We'll get there here in a second. But when you're in a class like mine, and let me make a really simple class sort of setup like mine. Let's say that the test average is worth 50%, and the quiz average is worth 10%. So then the final is worth 40%. So thank God they all add up to be 100%. How the hell do you calculate your average here? All right. So if you, let's say your test average was a 81, and your quiz average was a 92, and the final you just had a crap day and you got a 69. Your alarm didn't go off. You spilled coffee on yourself. Right? Everything just went wrong. Your pencil broke. Your second pencil broke. All right, but how do you calculate the average? I mean, it cannot be just add these up and divide by 3 because they're differently weighted, right? So 50% of your grade is based off of 81. So you actually do 50% of 81 plus 10% of 92. We put the other one plus.
40% is 69.
So mathematically, it would be 40% is 0.4 times 69 plus 0.5 times 81 plus 0.1 times 92. So somebody help me out there. It's like 77 or something. My brain is giving up on me.
77.2.
Okay. So you have a 77.2 average, right? And you come say, is that enough for C+? No, it's too bad. Nah. You're right. You guys kind of with me? Because the other kind of class would be set up with points, right? Have you ever had that kind of class? Mm-hmm. Where the midterm is 500 points and whatever, right? Yes, ma'am. No, because you would divide it by the total percent, but the total percent is 100% or 1. So if I haven't taken the final yet, and I want to know what my average is, I would do 0.5 times 81 plus 0.1 times 92 divided by 0.6. Because I've only done 60% of the work. If I've done all the work, I would divide it by 1, which is 100%. I love it. So that's why I don't have to worry about dividing. Maybe. All right, so there might be one problem like that in the homework. If I cite it, I can't remember. Okay, so that's section 3.2. So 3.2 is not that big of a deal. 3.3 is. So I want to get a little bit into 3.3, and then we'll continue to 3.3 next time.
Okay.
Yes, measures of spread. Or variation. So what we're trying to do is to come up with a summary of a set of data. So if I had 500 data points, I don't want to continuously give all 500 data points to every person that I'm going to talk to. I want to summarize that for people. So, yes, ma'am.
5 numbers under. That's why I was putting on my hand.
Oh, okay.
Numbers under.
That's one way to do it. The shorter way to do it is to give them 2 numbers. Tell people where the center is. And in general, what wins out is the mean. We're going to use the mean for most of our work in this class. It adds a couple of failings with like income and so forth. So we've got to be careful when we hit some of those. But the mean is what we're going to use most of the time. So I give somebody the measure of center, which will normally be the mean. And then I tell them how far away do the data points get away from that mean on average. Let me let that sink in a little bit. So if I had data, and if I try to plot the data, I get data that looks like this. There's one way over there. If I can tell somebody where the middle is, And on average, how far away that data is from the middle, that gives somebody a really good feel for the data itself without having to look at the whole damn thing of data. Right? So, for example, a normal, you ready for this? So I always teach all my classes about standard deviation, even if they're not stats classes, because I tell people the average. So, for example, I gave back a quiz this morning to my pre-calc class, and it was horrible. It was the average like 67. Bummed me out a lot, but we had a big talk. The standard deviation for tests and quizzes are normally 11 to 14. So right now that doesn't mean shit to you, but this is a measure of how far the grades got from the center on average. So of course, the further the grades are spread out, the larger that number is, because they're further away from the middle on average. Are you guys kind of with me? It's going to get a lot more detailed in a minute, so just enjoy it while it's not. So normally it's like 11 to 14 at the very most. The standard deviation for this quiz was 18, which means what? From that limited amount I've told you, can anybody figure out what that might mean about these quiz grades? From the center, whatever the average was, whatever the mean was,
The average
the distance away from that average was bigger than normal, which means somebody scored really high and somebody scored really low. In fact, a decent number of people were down in the 30s, and then a few people were up in the 90s and 100, right? So that's a huge spread. You with me? So normally I don't like necessarily a giant spread, and I really didn't like the average, right? But that's sort of the idea. That's what we're trying to get towards, because those two numbers together are what make the most sense to summarize a list of data. Does that kind of make sense? Mm-hmm. Yes, ma'am.
And like that number, because you said like 18 apart, that would change if it's like a bigger number, like the average if it's bigger than... Like,
yeah, so depending on where the data all are, then the average would move around, right? But if the data are far away from that mean, wherever it is, right? So I could have, now watch this. Let me give a little more specific example. I could have something silly like this. What's the average there? Let me call this, let's call these populations for right now. Yeah, the average in Kremlin is 3. Not much work to do. What do you think the standard deviation would be? We haven't even talked about what the hell is how to do this, but what do you think the standard deviation would be? 0, because it gets 0 away from the mean. Everything is the mean. What's the range also? 0. High minus low is 0. Okay. So then you might say, why the hell do we need the standard deviation thing? That sounds like it's going to be complicated, because you're all like, we got to do it across 2 days, and oh shit. Why don't we just stick with range? Well, I'll show you why. Another way to make an average of 3 would be to do this. Right? That's still going to be an average of 3, because it still adds up to be the same number, right? So the average is 3. What's the range? 2. Now stay with me. What about what's the average there?
3.
Yeah, why is it still 3? Because I just took one away and took one up, took one away, took one up. They all add up to be the same thing, right? So the average is still 3. What's the range?
4.
4. How are we doing so far? I mean, this is still not talking about standard deviation yet, but I want to give you one more example. What about this guy here? The average is 3 still, right? Because I took one away but added it there. So they still add it to be the same amount. So the average is still 3. Well, what's the range? 4. Now, if we thought we just needed the range, we definitely need the average. I'm going to tell somebody what the mean is as part of my summary of a big old list of data, right? I'm going to give them the mean of it. But by itself, that's not good enough, right? I have to also give them an idea of the spread, so somebody can imagine how spread out this data is. So if I said the average salary at this place, so everybody, there's no CEO, they're all like governing themselves, so nobody's crazy extreme. The average salary is $80,000. By itself, that's not good enough, because what if the spread is like $20,000 versus the spread being $5,000? Are you guys kind of with me? Or let's think about this. Do you guys know that there's a website, and if you didn't know now, you would eventually, where you have to pay money, thankfully, but it shows you the grade distribution of teachers over their entire history, right? Yeah, it's out there, right? Because it's public domain knowledge. Actually, that's why they could put it out there. So if you saw that there were two teachers, there's two teachers that they both average a C. They both give a C out on average. But one teacher is spread between B and D, and the other teacher is spread between A and F. Now, if you're going to take the class and you're not really sure, now let's pretend you're at university where D's are okay, right? We're all here at Grossmont, C's, you got to get C's to transfer. But if you're at university, D, you pass that damn thing. Keep going. Right? So D is okay. So if you're going to take this class and you're really worried about it, and you don't think you're going to do that well, which teacher will you take? The B to D, because you're going to be the D. This teacher obviously doesn't want to fail anybody, right? Stupid teacher. Sorry, you guys have to fail sometimes, sorry. But if you felt that you were going to do kick-ass in this class, you just knew you were going to eat this class up for lunch, you would take the A to F. Because you're like, yeah, I've taken a class where the teacher would not give an A unless God took his damn class. I'm still a little bitter about that. With the highest grade, it was a B. I'm like, you suck. So, anyway. Someday I'll get over that. But do you guys understand how, if I have a whole bunch of data, and that's like historically, over all the classes they've taught, if I count up all the students I've ever had, I've been teaching since 1998. That's a lot of freaking grades I've given. But all I have to give you is the average and the spread, and you have a really good idea of all the grades I've ever given. You kind of with me? So that's why those two numbers make sense. Is the range good enough? The range claims that these two are the same. It's not the range's fault. The range is just too simplistic. Are these two the same? Which ones? All right, this could not go the way I wanted to. Which one is more spread out? Meaning the data points get further from the average. Which one? 3 or 4? 4 obviously is more spread out, right? They get this 2 and 4 are closer to the average, aren't they? So the standard, if I did the standard deviation for this and the standard deviation for that, it would be bigger for this one. So the range is not good enough for that second summary number I want to get. To give somebody the idea of the spread, because the range doesn't differentiate between those, and they're obviously not equally spread out. Okay, good. So, let's get a little bit into building the standard deviation. Cool. Everybody's starting to look at the clock. Because this is a little bit like watching, well, it's not exactly like watching sausage being made, but you guys don't get to see how we create equations very often. So statistics is really good for this, because you have something you want the math to do. You have a very specific, I want you, math, to tell me a number that tells me the spread. So you can force it to do what you want it to do. It's really cool. You guys aren't used to that. You're used to, here's y equals mx plus b, and you use it. You're not used to, like, I want it to do this. So you guys in statistics, you actually get to see, and somebody goes, I don't want to see this, too bad, where the equation comes from. So I'm going to go through a whole lot of stuff. You just absorb what you can. You're not going to have to repeat what I'm doing. I'm showing you the derivation of the equation. You're never going to have to do it yourself. It might be a bonus kind of question where I ask you some stuff, but I'm not going to make you re-derive the equation. Let me leave that up. Well, let me take this away. You guys have this written down, right? You guys can help me out later when I need it again. All right. So we're going to create this standard deviation. And let's do it for, I'm going to represent the data in a slightly different way. I'll list it more like on my calculator, right? So let's do the one for the 1, 2, 3, 4, 5. Let's figure out how we can get a hold of this measure of spread that we want. So obviously I'm going to lead you a little bit, right? Because this has already been decided on, so we basically have to agree with it. But I want you to see why it makes sense. You guys agree with me the way I phrase this? I want this number to be the average distance from the center the data points have, right? How far from the center they are on average. That would be a measure of spread. Is everybody kind of cool with that?
Yeah.
And you're like, just to keep this going, yes, Jeff. Okay. So the first thing, how do I average anything? Add them all up and divide by them. All right. So if I want to find the average distance, I first have to find all of the distances. Right? That makes sense. So what was the average here again? I think I said this is a population for now. Yeah, it was 3 eventually. So how far, let's just be really kind of silly about this. How do I find the how far apart two numbers are? What operation do I use? Subtraction. I love it. So I know some of you guys have something else in mind on top of that, but just let's go with subtraction for a second. So I want x minus the mean. Wouldn't that be how far each data point is from the mean? Sort of. There's still a little bit of problem with that. So this by itself is called the deviation. It's how far a data point deviates from the mean. Okay, you with me? So for example, if I knew the average age of Grossmont was 27, and I pick some random person, my best guess for their age is 27. Because they should be kind of close to it. Now, of course, I might pick somebody that's really old or really young. It's possible. But my best guess would be 27. Right? So that's why it kind of makes sense that we want to talk about how far does each data point get from that expected value. So, Courtney, what would it be here? -2?
And 1, 0, 9.
So that's easy enough, right? Now, some of you guys already see the problem. They already knew the problem, especially because I said the word distance earlier. But if I try to find an average from this, I'm always going to get the same problem. What do you get when you sum these up? 0. Well, that sucks. Every single problem, it would be 0 because there will be equal amounts negative versus positive because the average is in the middle of all the data points values. The median is in the middle of data points, but the average is in the middle of their values. So you'll always have this add up to be 0. That really sucks for us because if it's 0 for everything, what good is it? It doesn't tell me anything. So what's one way I can take care of this? What's better for distance? Or actually, what is distance in mathematics? What do I have to use for distance?
Absolute.
Absolute value. That's how absolute value is defined, right? That's why it's always positive. Because you can't be -4 feet away from me. I don't care which way I'm facing. -4 feet being you're like in me or something. It's kind of weird. So let me quickly dispel using absolute value, and let me try to explain a little bit why we don't. Because what's another way I can kill negatives? Squaring, and we actually use squaring. So let me explain a little bit why we don't use absolute value. What does absolute value look like if I graph it? Yes, like a V, right? So it doesn't turn nice. It goes, okay, yeah! So if you did this in a plane, you would die, right? You can't do this. So a lot of mathematical processes do not like that hard turn. You with me so far? So that's one reason, and I'm not going to get into the real whole reason we don't do this. This is enough for now. That is one reason we do not use absolute value to kill these negatives, because some other stuff I want to do with this would freak out with that hard turn. But if I square things, what does that look like? X squared. Nice, we would survive this. Yay. Right? In fact, that would be fun. That would be a nice day at Busch Gardens, or I'm thinking about back in Virginia, sorry. Whatever amusement park you like to go. So we're not going to do absolute value here. We're actually going to take our distances, our deviations, and square them. And the whole reason we're doing that is so I can kill the negatives. Now, obviously, what do I have to do at the very end? Take the square root to kill all these squares, right? If this is the number of pets I own, I'm going to get square pets here. That's freaky. Right? So at the end, I better square root it so it comes back to normal units. Okay, good. So if I do both of those things, I've killed the negatives, allowed me to move forward, take a square root, I'm good. Okay, so here I get what? Cool. So when you add those up, sum of, now what would this be? What would the symbol be for this sum I'm doing? What am I adding up? I'm summing what?
X minus.
These. So the sum of the squares of the deviations. So the sum of the squares of the deviations. Right? So if you saw this sitting in a formula, you would know, oh, I've got to make that column so I can add the damn things up. You cannot substitute stuff in here. You can't. This says sum these up. You need a list of these to add them up. You with me? Okay, good. That's the big thing you have to be careful with stats and how it works with these summation symbols. So if you add them up, you get 10. That's crazy. Okay. So remember what we want to do. We squared them just to kill the negatives. So how do I find the average of these numbers now? I've already done part of the work. To find the average, I add them up and divide by how many there are. In this case, 5, right? So, stay with me now. And again, you guys, I want you to understand, this is stupid important. We're running through this once. We're going to run through it again, and then I'm going to let you out a little early, right? Because this is enough to fry our brains. And then next time I have a handout. One side will be completely worked out, and the other side you guys will work on at the beginning of class together to do this. And let me finish this idea. Chapter 3, homework and quiz and test, you have desperately got to show me this work. If you do not show me this work, I'm not going to give you any credit. So in homework, don't just turn in and say, I use the calculator because I know how to use the calculator. I don't care if you know how to use the calculator. The calculator passes stats. Yay, calculator. After chapter 3, after the test for chapter 3, after this first test, I'm never going to make you do these tables again. You with me? But you must go through this at least once to see what goes into making standard deviation so you understand it better. I don't like the little black box telling us what the hell the number is. You don't know what the hell happened. So to finish this out, here's a symbol for standard, let me be careful. Here's a symbol for what's called variance. I can't call it standard deviation yet because I'm not going to have taken a square root yet. So this is what's called the variance. And it's given this symbol, and it kind of makes sense. I know I want standard deviation eventually. I'm going to use the Greek letter S. Not sigma, though. I'm going to use the lowercase s. So in Greek, it's sigma. Lowercase sigma. So how do you make this? Because I love people just call it R. Be careful. R is something else entirely. So how do you make this? You start in the middle, and you wrap around. Like that. See it? So depending on how I'm feeling, I get skinny sigmas or big fat ass sigmas. Right? I'll take either one of those. But I don't like R. No. Right? So practice that. It's a whole different language. We don't write Greek a lot. Maybe you do. I don't know. Anybody Greek? Okay, see? None of us really write Greek. So it's sigma squared to remind me that I have not square rooted yet. This is the add up all the squared distances divided by how many there are. So this is like an average squared distance. And how do I get the average distance? Bless you. I take the square root. So that would be the standard deviation. Would be the square root of sigma squared, which is sigma, square root of all that business there. Can't we just stop right there for a second? Let you guys catch up.
So sample would just be S squared.
For sample, it'll just be an S. We'll get there eventually. Today I'm just focusing on population. Because sample has a whole different denominator, so we got to talk about that.
Yeah, it does. It's like
Don't
n
worry,
minus
we're not
one.
there yet. Don't worry.
The n minus 1.
Oh yeah, gets a little freaky. Now, if I would have just thrown this up on the board earlier, even some of you guys are still looking at it like, oh God, what the hell? But do you remember what went into doing this? A list of numbers. And I just realized that if I make these, they're just numbers, and then this says add them up, okay, just add the damn things up. So we really just have to realize the shorthand that is math, the other language that is math, and what it's asking me to do. It's not asking me to do crazy, terrible stuff. I can subtract, I can square, I can then add those numbers up. You just have to know what these symbols mean and what order to do them in and all that kind of stuff, right? Okay, good. So what do I get for this, for the variance, for this data? It's going to be the sum of the squared distances, or deviations, sorry. So you get 10 divided by 5. So I get the standard deviation. The variance is 2. Yes, ma'am.
Is that supposed to be squared still?
Yes.
Okay.
Yeah. Because I haven't done what yet? Square rooted yet.
Okay.
So the variance is you just take the squared stuff divided by n. Standard deviation is you take the square root. So what's the standard deviation going to be? So if you have the, let me do this all. So if I have variance is 2, standard deviation is the square root of that. So roughly what? Give me to 3 decimal places. 1.414. And I know in algebra we did a plus or minus there, right?
Yeah.
It's good that you remember that. But this is always positive because, again, it's an average distance. I want the positive root. Standard deviation can't be negative. Okay, cool. So what that really means is all these data points are, on average, about 1.4 away. It's not perfect because we squared instead of absolute valued because the other math we want to do doesn't like the kink in that picture. But it is pretty damn close.
The actual average.
Yes. Cool. So it's roughly 1.4 away from 3. Every data point is about that far away from the middle. That's what that's trying to get at. So let's do it real quick for the last list of data. Remember, this is 1, 2, 3, 4, and the last list was 1, 1, 3, 5, 5. So let's do it for that. That's still 3, and this is all still okay. So let's take this out. Okay. And of course, the standard deviation for the one I just did was 1.414. Who could make a prediction for the standard deviation for this? It should be bigger. I like it, right? Because on average, the data points get further away from the middle. So if it's not bigger than 1.414, I got to throw the whole damn thing out. We can just leave and never come back. So you're all like, come on. It's not going to happen. So again, what would this be?
-2, -2,
Yeah.
0,
Okay, cool. Yes, ma'am.
Is it possible if the numbers are that you can just have the difference between them, or you have to
Do again.
have the difference between them, or you have to do all that?
You have to do all this.
So you just see the same answer.
The same answer is doing what now? What, just looking at how far apart each one is? So if you try to do that, well, we got them right there, right? Then you get the whole problem with the negatives in there. And if you use the absolute value, it's not going to jive with some later mathematics that we want to do. So it's not going to be the right number that we use. And in fact, that's what's called the, I gotta remember, the standard error. If I'm remembering correctly, if you use the absolute value, it's called the standard error, and it's almost never used because of that whole kink in it, right? All right. So what do I get here? Yeah, you square that, so you get 4, 4, 0, 4, 4. So what's the sum of those now? 16. So then the standard the variance would be the sum of these divided by 5, the number, divided by the number. What's that?
3.2.
3.2. And then the standard deviation is the square root of that. Standard deviation, you always take it out at least 3 decimal places. 1.788. And is it like we predicted? Yep. That one was only 1.4. This is 1.788. That's bigger, like we predicted. Cool. So the standard deviation, this number we've created to do what we want it to do, does what we want it to do. Thank God. And of course it does. We made it do what we wanted it to do. Okay, maybe. So, let me see. On page 97 in the new book. Anyway. Actually, wait. Where's the... No. You guys are funny. Oh, that's funny. They don't give it this one. They only give the standard deviation for sample. That's weird. Silly book. Oh, here it is. Okay, good. So for some reason they do this second. It's always good to start with this. Here's the standard deviation for a population. That's just like we did, right? Now what we're going to talk about next time is when you have a sample, and actually I'll talk about it a little bit now, because I just can't let you have this early, is this. And notice one little thing that's different about this. Well, two things are different, right? Of course, I didn't use the symbol mu. They use the symbol x bar because it is a sample we're using. But the big difference is not divided by n. It's divided by freaking n minus 1, right? So I'm going to attempt to start to talk about why that makes sense. And then I'll still let us out early, so don't worry. I won't lie to you. Because that means they'll let me out early, too. So, yeah. So there's a certain average. I always go to age because it's just easy. There's a certain average age in here, right? So there's a certain standard deviation for everybody. You with me? Standard deviation of the ages in here. Cool. If I picked a row of people, do they have the same average age as everybody would? I would put money on the fact that they don't, right? So maybe a certain row is young, or a certain row is older, right? So say I pick you guys, and you guys happen to be a little bit younger than the average age of everybody. You with me so far? Well, no. Yes. So their average age is a little bit lower. Their average age is closer to their ages. Wouldn't it be? So if I take any row, the average of that row's ages will follow those ages. It'll because that's where I get it from, right? I average all the ages together. So that means the distance from each of your ages to that average of your ages will be smaller than it would have been if I was looking at everybody. So if I take a sample from a population and calculate its standard deviation, it's always going to be smaller than it really should be. Let that sink in. Because all the ages will be closer to their own x bar than they would be to mu. Right? Because mu would come from their ages. So of course it's going to be closer to their ages. So how do I make a number bigger? If I'm dividing by something, what would I divide by instead to make it a little bit bigger? I would divide by something that's a little bit smaller. So I don't divide by n. I divide by n minus 1. Okay. Now that's not the whole story. That does explain why the bottom is a little bit smaller, because it's trying to counter for that effect. That, yes, you do follow your average, so you're going to be a little closer. So your standard deviation is going to be always a little smaller than it should be. So that makes it a little bit bigger. Kind of accounts for that. Okay, good. So just remember that. We'll get a little bit more into this next time, but that's the adjustment for the fact that this is a sample. So that's why it makes sense. And this is what statistics is really all about. The formulas are basically the same, but they have little differences based on your situation. So that's the conceptual part of this. You have to figure out which formula, which variation do I use given this situation. For a sample, I use that one. Cool. That's, yes? Say again, sorry? Yeah, look up here. We'll talk about this formula next time. It's like that formula but moved around. And this is actually a stupid way to do it, but I'll show you a better way. So this is the one. The only real difference, see how the X bar is there? And that's just because it's a sample. So the real substantial difference is that -1. Right? Cool. All right, guys. So next time I'll have the quizzes graded.